Hi there, welcome to part 3 of our Spring SKYWARN Spotter Training. My name is Abby Gann. I'm a meteorologist here at National Weather Service Albany. And in this section, we're going to be talking about thunderstorms, specifically the clouds, lightning, and hail that can be resultant from thunderstorms. So with that, let's get started. So based on this climatological study done from 1945 to 2022, we can see that typically in Albany, our greatest amount of thunderstorm days occur within the summer months, or June, July, and August. But what exactly is a thunderstorm day? What does that mean? So let's take July, for example. You can see the value here in this bar graph is 5.7 thunderstorm days in July. And what that means is that on average, in this period from 1945 to 2022, the month of July averages about 6 days that experience thunderstorms. So we're not looking at an average of 6 thunderstorms per day in the month of July. We're looking at about 6 days in the month of July that typically have thunderstorms occur. So on average, as a whole for Albany, within all of the months, all the 12 months, we typically see about 24 thunderstorm days per year. So just because we see the most thunderstorm days in July and then June and August following that, it doesn't mean that we couldn't see thunderstorms in any other month or in any other season. It just means that these 3 months hold the most thunderstorm days or the most frequent occurrence of thunderstorm days on average within this period. And that makes a whole lot of sense, and will a little bit more as we start to get into a little bit more about thunderstorm development. But essentially for us, July holds the most thunderstorm days on average in a given year. So how do thunderstorms develop? How do they form? We meteorologists like to rely on our 3 ingredients method. There's a whole slew of ingredients that kind of go into, or factors rather, that go into thunderstorm development. But really what we look for right off the bat are these 3 things: moisture, instability, and a trigger, or some sort of lifting mechanism. We really want rising air, or a lot of rising air. So these are the 3 things that we look for right off the bat. So being here in upstate New York, we have 2 main moisture sources that we look for, or at least look to have winds blowing off of to get us some really rich moisture up here. So when we have this kind of southwest to northeast flow off the Gulf of Mexico, that's one way that we can get a lot of rich, moist air coming up into our area. And then also when we have this nice southeast flow off of the Atlantic, that's when we can also get a lot of moisture in our area. The next is instability. And if any of you read our forecast discussions, you may have heard us mention, or you might have read us mention, or seen us mention, that we want breaks of sun in order to have thunderstorms develop in the afternoon. And so really when we say instability, what we're really talking about is heat. We want a lot of heat in order to generate thunderstorms. And the reason being is this idea of buoyancy, right? So warm air is less dense than cooler air. So what we want is the air at the surface to really heat up and get nice and warm, so it becomes lighter than the air maybe a few hundred feet above it, right? It's going to start to rise and lift up a little bit. And kind of just make this displacement of air at the surface. And so then when we initiate a trigger or a lifting mechanism, such as a cold front, for example, that's going to take that warm air and really drive it vertically into the atmosphere, then we get this really strong updraft, or updrafts, plural, even with thunderstorms. We get this really large upward vertical motion to be able to grow these thunderstorms. So like I said, there's a lot of different factors that go into thunderstorm development, but these 3 things are the main things that we look for right off the bat. And these are the things that when all combined together are typically going to give you your thunderstorms. So let's talk a little bit about the cloud formations with thunderstorms. So I mentioned earlier that we want warm, moist air that's going to rise up into the atmosphere, right? And that moist air is also less dense than cooler air. So that's another reason why we kind of want all of these ingredients together, because they all ebb and flow with each other, or kind of go hand in hand with each other. So at the towering cumulus stage, we start with this kind of baby looking cloud, right? It's really small. It's got a little bit of vertical height to it, but all of this warm, moist air is moving upward. And so then we get this cloud that starts to form, because our cloud processes start to go in together. We start to get condensation, and we develop a cloud. And so it starts to rise, and it gets up past the freezing level. But at this towering cumulus stage, we have it growing vertically, maybe up to a height of about 20,000 feet or so. And the air within the cloud is dominated by that updraft. I mentioned the updraft earlier. That's this vertical motion of upward vertical motion of warm, moist air. Then we translate to the mature cumulus stage. So in this stage, we still have this warm, moist air that's rising throughout the cloud, but now it's going a lot of different ways. This cloud has grown potentially to depths of 30 to 50,000 feet. The strong updraft still exists there, but now we have the development of precipitation that's going to make this really cool downdraft area, because like we said, that cooler air is more dense than warmer air. So once we've reached past the freezing level, now we're getting air that's really, really cold within this cloud. And so then we're also, again, continuing to go through all of these different processes to make the rain. And that's going to pull some weight down on the backside of this cloud to make this really nice, cool downdraft. And then and then in this stage too, this is typically the most dangerous stage, where we could potentially have tornadoes, large hail, damaging winds. We might even have flash flooding if there's a lot of rain being produced within this storm. So that's our mature cumulonimbus stage, where we have the most dangerous storms at this point. Then we translate to the dissipation stage. So eventually what happens is these updrafts and downdrafts begin to merge together, or the downdraft starts to undercut the updraft, and we stop the flow of vertical motion upward, because the cool air starts to cool off the warm air, and now we're going to start having that air sink back down to the surface. So the downdraft cuts off the updraft. There's no longer a supply of this warm, moist air to maintain the storm. So now we have this cloud that starts to really shrink upward and leave behind just a remnant anvil top. So really just a flat cloud. We might still get a little bit of rain, potentially even virga, which is rain that doesn't exactly make it to the surface. But we don't have this thunderstorm anymore. So we also have what's called supercell thunderstorms. Now, the thunderstorms that I just talked about on the previous slide, they're your typical thunderstorms that you can, or your run-of-the-mill kind of thunderstorms that can become strong at different times and can certainly still be dangerous. But these supercells are a special kind of thunderstorm that persists for many hours. The last thunderstorms that we talked about might not last that long, maybe 30, 45 minutes, maybe even an hour. But supercells are such strong thunderstorms that they can persist for many hours. They're responsible for nearly all of the significant tornadoes that are produced in the U.S. They're also responsible for the largest hailstones. And then they can produce extreme winds, upwards of 80 to even 100 miles per hour wind gusts. And then they can produce flash flooding as well, because they last so long and dump so much rain that it's just, some surfaces are very unable to keep up. So the most ideal conditions for supercells occur when the winds are veering or turning clockwise with height. So really what you want, we always talk about shear. We want shear in our clouds, in our thunderstorms, because that's going to tilt your storm so that updraft and downdraft zones, they remain separate for a long time. And that's why these can last so long. And then typically we can get supercells in this area, but they're typically not as strong as what you might see out west in the plains or in Tornado Alley out in Oklahoma, Texas, Kansas, things like that. So when you have these large thunderstorms, they have these different types to them, right? So you've got your tornado, they're very typical. You've got these big cumulonimbus clouds, a wall cloud that's typically rotating, an anvil, overshooting top flanking line. So there's a lot more parts to it rather than it just looking like this big white puffy cloud. So again, we can get them up here. It's just not as common. With thunderstorms, here are a couple of other cloud formations that you might typically see. The first is scud clouds. Generally, these are non-rotating detached clouds that are found beneath nimbostratus, cumulonimbus, or altostratus, or even cumulus clouds. And they're typically harmless. They kind of just look like shreds of clouds. But it is something that we like to monitor because they're so light and there's so many fragments of them that sometimes you are able to see rotation if they're kind of swirling around a wall cloud, for example, or something like that. But a lot of times we'll get people saying that they think they see a rotating wall cloud and it's just scud. So just keep that in mind, that if there's just a lot of little fragments of clouds around, it's probably just scud clouds. But it could be something to watch, especially if there is rotation within that thunderstorm. It may be the beginning of a formation of something more dangerous down the road. So then we have mammatus clouds. They're a cellular pattern of pouches typically associated with anvil clouds and severe thunderstorms. They can be indicative of strong thunderstorms, and they're also indicative of convective-induced turbulence for aviation. So that could be potentially detrimental to airplanes, could cause a lot of turbulence and kind of rough flights. So these are very pretty to look at visually, but again, they can be indicative of some severe convection or thunderstorms. So always be mindful when you see these types of clouds. Then we have shelf clouds and wall clouds. So for a shelf cloud, these are low horizontal arcing clouds that develop along the leading edge of a gust front. So all that cool air in the downdraft of a thunderstorm ends up racing out ahead or can end up racing out ahead of the thunderstorm itself. And so that creates a gust front, and it can be really strong. And so that can create a lot of really strong wind gusts. So they can occur along the leading edge of a gust front with an approaching squall line. And it's an indicator, like I just said, of strong to potentially damaging straight line winds. And then they're typically followed by rain as well. Then your wall cloud could be rotating. It's typically rotating, but it doesn't always have to be. It's a lowering of clouds underneath the base of a cumulonimbus cloud, which can sometimes be a precursor to tornado development. Typically, when you have a wall cloud, that's where your tornadoes are going to then form from. So that's always definitely something to watch, especially if the wall cloud is rotating. If you can see rotation in that wall cloud, it's definitely something to monitor and be wary of. Lightning. So lightning is extremely dangerous, no matter if it's your typical run-of-the-mill or garden variety thunderstorm, or you have a supercell. Lightning is extremely dangerous. So just some do's and don'ts. We always like to say that when thunder roars, go indoors. So if you're close enough to hear thunder, the lightning is close enough to hurt you or harm you. So make sure that when thunder roars, you go indoors. But don't just run into any kind of shelter that's available. You don't want to go into any dugouts, sheds, pavilions, picnic shelters, or any small structures that might not be the most stable, right? You want to find a sturdy house, a building, a car with a roof, something that's going to be a little bit more sturdy to protect you from the impact of a lightning strike. And then we also say to remain indoors for at least 30 minutes after you hear the last thunder clap. And then when you're inside, don't touch electronics outlets, corded phones, or windows. Make sure you're just staying away from those things because electric shocks can come through those areas. And never, ever, ever, if you're under or if you're outside, excuse me, go under or near tall trees. Swim or be near water. Trees and water and metal objects can serve as dipoles for your lightning. So make sure you keep away from that. So just as a general safety rule, if it takes less than 30 seconds to hear thunder after seeing the flash, lightning is near enough to pose a threat. So, and then after the storm ends, wait 30 minutes before resuming outdoor activities, just so that you know that the storm has cleared away from where you are so that you can remain safe. So unfortunately, lightning does cause a lot of fatalities across the United States. So this is not just for Albany, this is for the United States as a whole. The good news is that we're not necessarily seeing increasing trends, but the downfall, or the kind of not so bright side, is that we're not really seeing a dip in fatalities either. So there's still one fatality, obviously to us is always one too many. So there's still plenty of fatalities that happen every year, and we certainly want to continue to cut back on the number of fatalities, weather related in general, but especially for lightning. So lightning strikes the United States about 25 million times per year. It's pretty insane to think about. Most lightning occurs in the summer, but people can be struck at any time of year. Like I said, referring back to those thunderstorm days, you can have thunderstorm days that happen in any month, not just the summer months. So always be cautious about lightning and where you are in terms of in reference to thunderstorms and things like that. Lightning kills about 20 people in the United States per year, and hundreds more are severely injured. So please just heed the warnings that we give you and the education that you have, and let others know of that education as well, so that we can make sure that we're continuing to cut back or cut down on the fatalities that we have for lightning every year. Let's see if we can play these. These are just a couple of really cool lightning videos, so I'll see if I can play them.
Damn! Holy!
Okay, and then this one.
Get that big anvil strike last night.
I wasn't even out.
I got it!
So we have, from these videos, we can see one group of people, let's say, were safely inside, thank goodness, when lightning struck the tree on the left hand video, or the first video. And then another group of people were a little too close for comfort. So just always make sure that if you hear that thunder, to go inside and protect yourself. All right, so let's talk about hail. So we talked a little bit about the thunderstorm formation. So we can kind of see in this graphic here the mention of our warm updraft and our cold downdraft. And I talked about how we have our precipitation processes that go on, and we end up getting rain that falls through these thunderstorm clouds. But we can also get hail as well if our cloud grows to a certain extent. Right, so we have our freezing line here, this 32 degrees Fahrenheit line. And so our warm updraft continues to move into further up vertically into the atmosphere. And we have our thunderstorm cloud that continues to grow further and further vertically. And so what happens is this cloud gets extremely cold. And so some of the raindrops that end up forming start to freeze. And so within this thunderstorm, the combination of the updraft and the downdraft creates this circulation. And so as these raindrops are starting to freeze, and even if they're not freezing necessarily, and they're super cooled, meaning that they have a temperature that is at or below freezing, but they're not exactly frozen, they start to collide with each other and they form these hailstones. As long as they have something to freeze onto called a hail embryo. And so the hail continues to circulate and grow in these thunderstorm clouds until they're too heavy for that updraft to hold. And then they start to fall down to in the cold up downdraft. And sometimes, or once they get below that 32 degrees Fahrenheit level, they'll start to melt a little bit. Some may melt completely before they fall to the ground if they're small enough. Others fall to the ground at different sizes, just because of how they, just depends on how big they are and how, how much they were able to be sustained and grow within that thunderstorm cloud before they fell. So here's a brief video about hail formation. All right. So, like I said, hail varies in its size depending on the strength of your updraft, the strength of your storm, how high it grows to, how long it can sustain that hail rotating through the thunderstorm. So we do look specifically at hail size. And so when we send out warnings, we like to look at the different factors within the thunderstorm and try to send out our warnings based on the hail size that's present. So we can get hail that's as small as pea size, and then there's hail that can grow to the size of grapefruit or 4.5 inches. That's not typical up here. That's more typical with those supercell thunderstorms that happen out in the plains, but it's not a non-zero probability, right? So, if we get a strong enough thunderstorm, it is certainly possible. So we have a lot of different hail sizes, but what starts severe size hail is an inch or a quarter. So it goes all the way from a quarter to, again, that grapefruit size hail. So when you get when you are able to download your spotter information sheets, we will have something like this or a chart like this that shows you exactly what the severe hail starts at, how to measure it, and things like that. But again, these are what we look for. This is the wording that we put into warnings, where we might say, have a warning that mentions ping pong ball size hail, or 1.5 inches, maybe just quarter, up to 1 inch or so. So with hail, this can obviously be very dangerous for many different reasons, right? If you're outside and there's large hail that's falling and it hits you, that could cause serious injury, especially depending on how large the hail is. But there are times too when you might get caught in a hailstorm or a thunderstorm that is producing hail that could impact your vehicle. And so certainly, as detrimental as it can be to you, hail can be detrimental to your car specifically as well. They're extremely hard, and so they can put cracks in your windshield, as you'll see in this video in just a second. So if you find yourself encountering hail while you are driving, stop or drive slow. Stay out of culverts or lowland areas. If you see a safe place that is close by that you can make it safely to, like a garage or some type of service station awning, try to get there as quickly as possible. If you have to pull off to the side of the road, make sure you pull completely off the side of the road. Try not to, hover around the shoulder. Try to pull completely off the road, because there may be other people that keep driving through the hail. They might not see you. Their vehicle may become impacted by the hail and they might not be able to see. So just make sure that you're pulling all the way off to the road if there is no safe shelter that you're able to get to. Don't leave your vehicle until the hail stops falling. Again, it can be very detrimental, especially if the hail is 2 inches in diameter, like this example here on the slide. That can cause pretty serious injury. So just make sure that you stay in your car. It will protect you and give reasonable protection. If you're outside your vehicle, or even if you're inside your vehicle, there might be a situation where hail has compromised your windows or maybe your windshield or something. Just make sure to cover your face and eyes. If possible, get onto the floor face down, or lay down on the seat with your back to the windows, just so that you can avoid potentially being cut by the glass. And then if hailstones fall into your vehicle, you're able to protect yourselves from that. So just as an example of how hail can impact your car. This is a video from Niagara Road in Columbia County. You can see there's a lot of damage being done to this car just from the hail that's falling. All right, that concludes section 3. Thank you so much for watching, and continue on to the next section.